Ready-Made Maths YouTube training. Teacher and teaching assistant training in mathematics. This is day 5 of our whole week on mastery in place value. We spent the entire week looking at lots and lots of apparatus and visual images and ways to manipulate different pieces of apparatus to show place value really effectively. We've delved into place value at 2-digit, 3-digit and 4-digit numbers in quite a lot of depth. What we're going to do today is take one very, very important aspect, which is partitioning numbers in different ways. So now we are definitely moving away from 742 being 700s, 4 10s and 2 1s. That's where it's going to start, but we're going to visualize it and explore how that number can be partitioned in different ways. We're going to look specifically today at 2-digit and 3-digit numbers, although the same principles will apply for 4-digit numbers and decimals and so on. So I really hope you enjoyed the sessions today. We're going to spend quite a lot of the time in the classroom, and we're going to also look at a song that's going to support the understanding as well. Hope you enjoy.
Welcome to day 5 of this week's Ready-Made Mathematics YouTube channel training. This week, if you've been following me for the rest of the week, you'll know that we're covering place value. This is kind of the final day of the 5 where we kind of pull it all together. We've done loads of work this week looking at resources such as base 10, we've looked at Numicon, we've looked at tens frames, we've looked at the Slavonic abacus, we've used cubes. What we've done is we've explored place value in quite a few different ways, and we've tried wherever possible to go to greater depth. A little bit further, not just the standard 376 is 300s, 7 10s and 6 1s. We've looked at what it actually means. We've gone into the number 1000 in a lot of detail. We've built up 4-digit numbers, 3-digit numbers, and quite a lot of work on the development of really understanding 2-digit numbers, especially through the use of base 10. Now, I've been mentioning throughout the week that on the final day we're going to be looking at partitioning in different ways. I won't be spending quite as much time in the Ready-Made Maths classroom today. Got a few little songs and a couple of PowerPoint things I'd like to show you later on that will take you through the idea of partitioning in different ways. But I wanted to start off in the classroom and look just, quite briefly at a few different resources that can help children to see that actually it isn't just about the value of the number, but what we can do with that number once it's been created. So we're going to be looking at the abacus, we're going to be looking at Numicon, we're going to be looking at base 10, and we're going to have a brief look at place value counters, which are down here. So we're going to be taking all of those resources one by one and having a look at how we can play around with them and just show children that actually there are hundreds of ways to manipulate numbers and to partition numbers. The value overall will still be the same, but the parts will be different. Let's start off just by looking at a resource we've used earlier on in the week. We're going to look at Numicon. We're going to take a simple multiple of 10. And when we talk about partitioning, usually the first answer as to what does partitioning mean, if you ask a child, or often many teachers, partitioning is to split a number into tens and ones, or hundreds, tens and ones, or thousands, hundreds, tens and ones, or tens and tenths, or wholes and tenths and hundreds. We partition it into those separate bits. Partitioning really is just splitting numbers into different parts, parts that make up a whole. It is really the part-whole diagram. The part-whole diagram that's a key element of mathematics mastery, that's a big part of the Singapore maths curriculum and White Rose maths and many of the other mathematics schemes now, is really what partitioning is all about. I have a whole and I'm going to separate that into different parts. Now that could be done with a number as simple as 7. We could take the number 7 and we could maybe put 7 cakes on plates and separate those cakes into 5 and 2, or 4 and 3, or 1 and 6, or 3 and 2 and 2. We're still partitioning. We're taking a number and partitioning it. We've done a lot of partitioning into 5 and a bit. So the number 7 is 5 and 2. The number 9 is 5 and 4. The number 6 is 5 and 1. So even that is, even the numeracy strategy, that was classed as partitioning. What we're now going to do is we're going to partition a multiple of 10. So let's look down here at the Numicon. What have we got there? I'm going to ignore the coloured Numicon for the time being. I'm just going to look at the multiples of 10. Let's see how many we've got. 10, 20, 30, 40, 50, 60. Now you wouldn't normally talk about partitioning 60. You'd normally talk about partitioning 62 or 67 or 64. We're now going to partition 60. Let's have a look. How do we partition 60? Well, probably a relatively simple way would be that. We've started with 60, that was our whole, and we've partitioned it into 2 separate parts. 30, 3 10s, and another 30, 3 10s. I think you could probably see, without me, explaining too many ways, but, there's very simple ways that we can partition it again. We can partition it into 40 and 20. We can partition it into 50 and 10, or the other way around, into 10 and 50. I think, either way around, 50 and 10 or 10 and 50. We can also partition 60 into 3 20s. We can partition 60 into 30, 20 and 10. And we can partition 60 into 40, 10 and 10. Now that could be a great activity. Give each group of children or each pair of children a multiple of 10 that's, let's say it's greater than 50, and just say, right, how many ways can you partition that number? Partition it into 2 parts, and then partition it into 3 parts. How many ways can you find? Really open-ended, really easy to do, and the children will see the answer straight away. They're not working out mentally, they're visually seeing the answer in a concrete form. Now, moving on from there, we could then swap one of our 10s for something that is equal to 10, which is 5 and 5. So I've now replaced it. Suddenly, how many ways can I partition 60 now? Well, if I just take that 5 and put that 5 over here, what have we now got? We've now got 25 and 35. How else could I partition that 60? Well, I can put my 10 over here, and I've now partitioned it into 15 and 45. What else could I do? Well, I could even do it as, like that. I could take my 5 over here and say it's 55 and 5. I'm still partitioning the number in different ways. Alternatively, I can partition my number. It doesn't really matter which way around I hold my 5s either. So I'll put the 5s like that. I've now partitioned it into 25, 25 and 10. Really, really simple. So many different ways that you can partition a multiple of 10 just using the 10s pieces and one of the pieces that make, well, two of the pieces that make up a 10. Obviously, there are many other ways, because I could separate the 2 5s into 5 2s, and there'd be so many more ways. But I think to begin with, just keep it simple and have one additional piece that makes it work. Let's move over to our next, it's the same number. We're still operating with 60. We've still got 5 10s, but we've now got a 7 and a 3. Again, similar into how we did it before. 33 and 27 equals 60. Or what we should say is 60 has been partitioned. The whole was 60. My parts are 37 and 23. The whole was 60. My parts are 27 and 33. My parts are 17 and 43. My parts are now 3 parts. 60 is 17, 23 and 20. Again, there's loads and loads of ways that can be manipulated. If you want to take year 2 or 3 children to even more depth, even with the small numbers like 60, I could just replace another 10. I've now replaced the 10 with a 6 and a 4. I'm not going all the way and just replacing it with 1s. There'll be so many different options. But what I can now see, at the moment, it is the same. It's 17, 23 and 20. But what I can do quite quickly is, move my pieces around a little bit, and let's have a look what I've got now. Well, let's have a see now. It's a little bit more interesting. I can now see that 60 is 27 and 17 and 16. It's now 27, 14, I'll put it right, the biggest number first, swap that one round. It's now 27, 19 and 14. Move this over here, and I can even, I'm getting a bit silly now because we are obviously got 4 numbers there, and we've now said 60 was my whole, and my parts are 17, 13, 16 and 14, which in effect really, 16 and 14 make 30, and 17 and 13 make 30. I just think you can have so much fun, you can have so much depth, you can have children just coming up with their own answers. The proof's there in front of them. That can then become abstract and can be written on a board as a part-whole diagram. I probably wouldn't go further than 3 parts to the whole, and I would always start off with 2. I'd start off with 2. How many ways can you find 2 parts? Get that sorted out first, and then develop it onto 3 for those children that have got that far. But you can see how easy it is to do. And what we've done by using Numicon and not by using base 10 is we've not kind of muddied the waters by having 7 1s that can be manipulated in lots of different ways. We've just got a 7 and a 3, a 6 and a 4. So I would say that's a really good starting point for children in Key Stage 1. One other activity that's probably even more straightforward and probably even more of a starting point than using the Numicon is just to start off with Multilink. We've been using this all week as part of the tens frames and putting them into a tens frame, but all I'm going to use are just 4 stacks of 10, which is obviously 40, and I'm going to just manipulate those and partition them in different ways. Now, if I had a partner, I can imagine my partner was holding that, and I was holding this. The whole is 40, the parts are 20 and 20. The whole is 30, the whole is 40, the parts are 30 and 10. I'm a bit limited beyond that, apart from 20, 10 and 10, so I'm going to go onto the table. At the moment, I've currently got that idea of 20 and 20, or 10, 10 and 20, or 30 and 10. Again, quite limited really with 40 there, but the great thing is because it's Multilink, I can immediately just snap a piece in half, snap a piece into 2 pieces, and I've now got, certainly wasn't half, and what I've now got are 27 and 13. My whole was 40, the partitions or the parts are 27 and 13. Swap those round, my whole was 40, the parts are 23 and 17. If I kind of snap the number rod in a different way, I've now got the whole is 40, my parts are 28 and 12, or 22 and 18. It's very, very simple, just to show both ways each time. Or finally, I just separate it a different way. This time I will split it in half. I've now got 25 and 15, or 25 and 15, or 15, 15 and 10. Such a nice activity, very easy to do. I probably would start off with that before moving on to the Numicon pieces.
At this point, I think it's worth showing you some of the slides from the sense of number visual place value policy. I have shown this a few times throughout the week, in particular yesterday when we looked at 5 and a bit and laying out 2-digit numbers and 3-digit numbers in different ways. What we can see here is very similar to what we did earlier on with Numicon. We can see a number. The number on the left-hand side we can see is 80, and we're showing that in a very simple version, let's say in year 1, 80 can be partitioned into 40 and 40, into 30 and 50, into 60 and 20. Just very, very simple. Even with the 60, you can see the 50 and 10, how it's been set out. So it's a simple way of partitioning the number 80. And over here, you can see a little bit like, again, like we did with the Numicon. We've exchanged one of the 10s for 10 ones. And so now we can make the 80, 74 and 6, 35 and 45, or 59 and 21. All the other options that we saw earlier on.
Very, very quickly, I've used the abacus quite a lot this week, the Slavonic abacus. I just want to show you now kind of the standard way that you would normally see partitioning in different ways done when you move beyond multiples of 10 into standard 2-digit numbers. Now what we're looking at here on the abacus is we've got 5 10s there and another 10 here, that's 6 10s, and over here I've got 7 1s. So I've actually made the number 67. All I want to look at is how would you partition 67 normally? Well, if you got arrow cards, you'd definitely have a 60 there and a 7 here. So 60 and 7 would give me 67. That will be your standard kind of year 1 partition of 67. But just by moving one set of 10, what I've now got is a completely different way of partitioning the number. I've got 50 and I've got 17. Very, very simple. All I've done is move one row of 10. I've got 50 and 17. I've now got 40 and 27. I've now got 30 and 37 and so on. It's a very, very simple partition. All I'm doing is just showing by moving a 10. I've now got, so I can talk the other way around, I've now got 47 and 20. I've now got 57 and 10. You know, it's the same thing. I've still got 67. I can prove that by putting that over there. There's my 67. Again, I'll remove 3 of my 10s. I've now got 37 and 30. Very, very easy to do and just shows partitioning in a different way at a very simple level. What we're going to do now is we're going to look at a resource that's very similar to base 10 but isn't quite base 10 as yet. We're going to look at number rods, which we haven't actually used since one of the very, very early videos. The reason I'm going to start with number rods rather than immediately go to base 10 is because number rods, actually like Numicon, have a rod that represents each particular number. With base 10, if I was making, for example, the number 8, I'd have to use 8 ones. With number rods, I would just use an 8 piece. So at the moment, without swapping it, it's just one particular piece. So the number I've created on the table is the number, I must separate the ones a little bit more as they are. I've made the number 63. I know it's 60 because of that 5 and a bit idea. 5 tens and 1 10, that's 6 tens, and there's my 3. Again, very, very nice activity. How, currently, if I'm asked to partition 63, I'll say, well, it's 60 and 3. I could get a card of 60 there and put a 3 there, but I've made the number 63. As soon as I move that over there, I've partitioned it in a different way. What's the number now? It's 63, but it's no longer 60 and 3, it's now 50 and 13. I pass another one over. It's no longer 60 and 3 now, it's now 40 and 23. What I tend to do at this point, as I pass that one over, which effectively makes 30 and 33, is generally then start with the bigger number. So we have 33 and 30. What have we now got? We've got 43 and 20. What have we now got? We've got 53 and 10. So very, very simple, just by passing, or you can just obviously just keep them all together as they were and keep them in a straight line, but we've got 60 and 3, 50 and 13, 40 and 23, 30 and 33, 20 and 43, and 10 and 53. Very, very simple, and because we're using this piece rather than 3 ones, at the moment the children are just keeping it as 3, and that can't be partitioned in any other ways as yet. Much more conventionally, we've now made the number 74. Not the 74? Yes, the number 74. We've made the number 74 with 7 tens and this time 4 ones. What I'm going to do now is pause the video, and exactly like we did a few minutes ago, just imagining it was a normal, relatively simple partition in different ways. Can you look at the 74 and decide how many ways could you very quickly partition 74 differently? Exactly like we did with the number odds a minute ago. When you finish that, because we now have 4, which can actually be partitioned again themselves into 2 and 2 or 3 and 1, can you see any alternatives for partitioning other than just doing moving the 10s to go with the 1s? So I'm going to pause the video now, have a little chat, basically write down as many ways as you can of partitioning the number 74. So hopefully, just using that system from before, we're kicking off with 70 and 4. With one move, very, very easily, I can now see that 74 is 60 and 14. It's 50 and 24. It's 40 and 34. If I want to keep going, that's another one. It's now 44 and 30. It's now 54 and 20. And it's now 64 and 10. Again, probably move those that way around. That's probably a better version of 64 and 10. But what we've done is we've shown a very simple partition in different ways. For children going to greater depth, that's when we can start manipulating the 1s as well. So we can start off with that idea of 70 and 4. I pass my 10 over here to make it 60 and 14, but then I've now made it 62 and 12 or 63 and 11. Starting with another one, if I initially had the 40 and the 34, which is definitely one of the ways to do it, 40 and 34, or just keeping it to 2 numbers, 42 and 32, or 41 and 33. Obviously, there are many more options. I would definitely make sure though that children are secure on the first basic way of partitioning in different ways, just by manipulating the 10s, and then we can start to develop it. But again, it is the part-whole model. It's 74 is 41 and 33, or more conventionally, 74 is my whole, 50 and 24 are my parts. There's also the potential, as before, of partitioning into 3 parts as well.
So far this week, we've not had a chance to do much singing, so I thought this was the perfect time to introduce one of my favourite songs. I've been using this for many, many years. This is a song from the Number Fun portal, as are all the songs that I've been using over the course of the last few weeks. This is a song called Partitioning. Number Fun portal has been written by Dave Godfrey. It's got like 250 plus songs with animations, full tracks, backing tracks, and loads of resources as well. This particular one, Partitioning, involves Papa T, who's over here, and his granddaughter who comes to visit him during the week. And each day, Partitioning cuts a certain number of logs, but then organises them, as we saw yesterday in the 5 and a bit section, into big stacks of 10. Once he's got a full stack of 10, 10 stacks of 10, he'll then eventually put them into crates of 100. What's lovely about this song is this is the song that introduces the idea of partitioning in different ways. The activity that we've just done with 74 with base 10, let's see how that exactly same activity works with the partitioning song.
To see him chopping wood, I love to hear him say. So Monday I went down to see old partitioning. Oh, when he laid his extra rest, he said the words that I like best. Child, would you move these logs with partitioning? There's 74 today.
And at that point, after that fantastic introduction, there's 74 today. How would you expect 74 logs to be laid out?
Child, if you take 70, I will carry 4.
Child, if you take 70, I will carry 4. What it then continues to do is exactly what we've done, passing some over. On the next line, where it says, child, if you take 60, I'll take 10 and 4. I usually encourage the children to also shout out the word 14 there. So, child, if you take 60, I'll take 10 and 4, 14, and so on.
Child, if you take 60, I'll take 10 and 4. Child, if you take 50, I'll take 24. Child, if you take 40 logs, I'll take 34. Well, thank you, child. That's partitioning.
Obviously, the same thing occurs the following day. This time, Papa T comes along in his van. Here he is. I'm just moving the animation on at the bottom here without the sound. This time, we can even pause the animation now and say, how many logs has Papa T brought today? It's not quite 5 and a bit with these logs, but it certainly is with the groups of 10. So you've got 5 10s here, which is 50, 60, and then 2, 4, 6. So we can see he's brought 66 logs. As it's going to say in a second. There's 66 today, 30, 40, 50, 60, and there's the 6 logs. What's going to happen from there? I will then obviously pause the video at that point and ask the children, can you get your 66 logs? And can you go through the process that partitioning is about to do? So I'd ask them to go from 60 and 6, 50 and 16, and then we'd put the video on and see if that works. I wouldn't try and do the whole thing together with the video until the children were quite skilled at moving between them, until they're used to the song as well.
There's 66 today. Child, if you take 60, I will carry 6. Child, if you take 50, I'll take 10 and 6. Child, if you take 40, I'll take 26. Child, if you take 30 logs, I'll take 36.
And so on. And there is a third verse for that one as well. I'm just going to come out of that now, just briefly. This is where it comes from the Number Fun pack. Here's the PowerPoint presentation, which is brilliant because that allows you to download that, and then in the future you can put your own numbers in. You don't have to use the numbers that are actually in the song. You can just put your own numbers in, play the backing track, and then the children can actually do the activity as you are singing the song to whichever number you've chosen. What we can see now is partitioning for lower key stage 2 rather than for key stage 1. I'm going to go past verse 1, which does actually do a very similar 2-digit number. Let's play this. As you can see, on the first day, we have 84 logs. We'll go past 84, because on day 2, what's going to happen now is suddenly Papa T needs a bit more space on his van, because he's now got, as we can see, set out in 5 and a bit mainly.
There's 168 today.
We've got 100, 6 10s, and 8 1s. And we can see that's 2 away from 170. Let's see what happens with these logs.
Child, if you take 160, I will carry 8. Child, if you take 150, I'll take 10 and 8.
80.
Child, if you take 140, I'll take 28. Child, if you take 130, I'll take 38.
And that will fit in with the base 10 apparatus that we're about to use shortly in the ready-made classroom. And finally, towards the end of this song, we meet a very different number that's really interesting to explore with the children. We can see now we've got a 3-digit number still, but we have got no tens. We've got 3 hundreds and we've got 6 ones. So this allows us the opportunity to set this up in class, to ask the children to get 3 hundreds and 6 ones, and to discuss what's going to happen when Party tries to pass a 10 over. Let's just move the song on to the beginning of the verse. Let's just have a see as it starts. Come on, Party. 100, 200, 306.
Child, would you move these loads with partitioning? There's 306 today. Child, if you take 300, I will carry 6. Child, if you take 290, I'll take 10 and 6.
And obviously you can see what happened there. We had to undo the crate of 100 logs. We've now got 10 tens. One of those tens gets moved over. That's even more effective with base 10 because you are basically regrouping 100 as 10 tens with different resources. You have the 100 piece, and then that can be exchanged for the 10 tens. So again, it's a really nice one to do. But again, don't just use the song and play the song. The song is absolutely fantastic, but use the song as part of a whole lesson on place value, where at different points throughout the lesson you're putting the song back on, let's say in year 3, and taking the activity a little bit further. Have the base 10 available, pause the song many, many times, don't just play it all the way through, and give the children the opportunity to manipulate apparatus and to really discuss the understanding behind the place value. If you do that, this is an absolutely fantastic song to use.
What we're going to do now is take that same idea into 3-digit numbers. And this is something that many children have difficulty with in year 3 and possibly in year 4, when they're asked by the teacher to show me different ways of partitioning a 3-digit number. And it's always done on the board. It's just written on the board as a kind of abstract activity where they're given a number such as 672 and said, how many ways can you partition 672? And because the children have never had the practical experience of doing it, it doesn't really mean anything to them. They've never seen it. Therefore, it's not CPA, it's not mastery, it's which children can look at a numeral and use mental arithmetic skills to do something with it, which is obviously immediately means many children can't get the answer correct or don't really understand what they're being asked to do. By doing it practically first of all, and then doing it visually through pictures, we can get rid of that. We can have the children that can see the number from the word go, they know how it can be manipulated because they've done it, they can then draw it and move things around with the drawing, and finally it can be something that's done in the abstract. Let's look at the table. And funnily enough, the number we are looking at is 672. As a very basic partition, guess what? It's 6 hundreds, 7 tens, and 2 ones. Now, I'm not going to go crazy with this one. I'm not going to create 500 different ways of manipulating this number. I'm going to show you relatively easy ways that children can be taken through this as a place value structure. The easiest way to begin with is probably just to move a 10. We've got 600, 70, and 2, exactly like we did with the 2-digit numbers, has now been repartitioned into 600, 60, and 12. That's it. It's still the same number, 660, and 10 is 670, and 2 is 672. I could continue to do that. I could just keep the hundreds as the whole, and I could just pass the tens over. Exactly like before, it's now 650 and 22. But because we are dealing with 3-digit numbers, what I think we definitely need to do, once we've moved a few tens around, is maybe go back to the start and just move 100. And what have we got now? Well, we've still got 672 because we've got 500s, or 500, we've got 170, and we've got 2. Now let's move some tens, and that's just taken, in fact, even if we just move 110, we've moved 100 and 110. We've now got 500, 160, and 12. A lot more children will understand that because they can visually see it. If they've done all the work that we talked about earlier in the week on place value, they can read these numbers very easily anyway. They can see the answer straight away and it makes sense. Let's just go right back to the word go then. I am kind of skipping forward quite quickly because obviously you would do an entire lesson or 2 lessons on just this part of the concept, getting the children to practice manipulating the apparatus and then drawing their own versions of what they've done. 600s, 7 tens, and 2 ones, 672. I'm going to put those 2 over there, and I'm going to put those 2 over there. What's the number now? It's 400, 250, and 22. Let's go back to the beginning. Same idea. Try again. 672. Let's move that one and that one. And this time, let's move those. What's the number now? It's 400, it's 230, and it's 42. It's 300, it's 320, and it's 52, and so on. It's 500, it's 140, and it's 32. It's still 672. It can be partitioned in so many different ways just by moving these around. I'm not going to go really into, yes, of course we could if we really wanted to, you know, do that and have, you know, 520, 120 and 32. That's where, again, you can take your children to even more depth once they've really understood the basic concept of moving the hundreds to go with the tens and moving the tens to go with the ones. You know, you can then partition it in as many different ways as you want.
And as we've just seen, here's a really nice example from the visual place value policy from Sense of Number. If you do want to get hold of this, it's just www.senseofnumber.co.uk. There's a whole range of different posters and wall charts that you can purchase as part of one policy that you can use in school to back up all the different elements of place value. This is similar to the example we just did in the classroom. We've got the 700, the 80 and the 3, and we can visually see them rather than just having a number 783 at the top. How can we partition that in a different way than 700s, 810s and 31s? Well, what I love about this is you can visually see what's happened. That 700 has now become 600 because the 100 has gone down here. And what we've also done is we've passed all of those 310s over here. So we can see exactly what's happened. It's now 600, 150 and 33. We'll then pass another 100 down to here. So that's become 200. We'll pass another 10 over here. So we've now got 500, 240 and 43. And finally, we'll pass a third 100 over and 2 10s over here. So we end up with 400, 320 and 63. So that's www.senseofnumber.co.uk if you want to have a look at that policy.
And just to finish off, again, we can use base 10 or we can use place value counters. I've not really made much of place value counters this week. I've shown them several times, but I've tried to keep it to the concrete apparatus where you can visually see the actual place value. But obviously, once the children have got that secure, the place value counters allow a number to be created and manipulated in much smaller space, but with the same understanding behind it. So let's move down to the table and look how much easier it is to create the number 863 than getting 800s, 6 10s and 3 1s, even though we are looking at 800s, 6 10s and 3 1s. Obviously, the place value that we will have done, if this was, let's say, a year 3 activity, will make sure the children understand that that 10 is worth 10 1s and that 100 is worth 10 10s. That's already been secured earlier in the block. So let's say this is towards the end of a block of learning and we're manipulating place value counters. What I'm going to do now for the final little activity is we're going to pause the video again. I'd like you to take that number now. I'd like you to possibly draw the place value counters as they currently are. And then just to see, first of all, just by moving one of the hundreds or one of the tens, can you create a very simple new partition? And then by moving more than one of the hundreds and more than one of the tens, how many ways, let's just say, can you come up with 5 different ways without really moving the ones, but it was 5 different ways of partitioning the number 863. Let's pause the video now. So possibly where you might start, as I probably would, is just by doing that. We started off with 800, 60 and 3. We've now got 700, 160 and 3. I've then passed that one over here and I've now got 700, 150 and 13. I can still go 750, 63. Sorry, 800, sorry, 700, 850, 63. I've got the same number I began with, but that's just the simplest way to do it. Once we've done that, we can move another 100 over. Just keep it consistent. We've got 600, 250 and 13. Move one more 10. 600, 240 and 23. And we can keep doing that, moving 100 and moving a 10. We've now got 500, 330 and 33. Or, going back to where we started, we can just start from here and say, right, just move some hundreds, move some tens, let's see what we get. And the children may then possibly move, let's just say that. What have we got now? We've now got 500, 340 and 23. They might even want to go for a really big number over here, you know, so put a lot more hundreds over there, so we might even end up with something like that. You know, we might even end up with something like that. We've got 640, let's say 200 and 23, or really go into depth, 640, 210 and 13. We know we've still got the same number that we started off with, we've just, you know, been a little bit more creative. And that's it for this week of place value in mathematics. We've looked quite a lot in greater depth this week. We've looked at so many different resources, and I hope you found the sessions really, really useful. I must just mention while I'm here, my mathematical t-shirt that one of my children bought me for Christmas. It is going into Key Stage 3 mathematics a little bit, with the adjacent side, the opposite side, and the hypotenuse. I do have a nice range of dodgy mathematical clothes that I do wear every so often. Anyway, let's just finish this particular session by just telling you what's in store for next week. Next week we are going to conclude the place value. I was going to do a part of the session today on decimal place value. As I was thinking about it, there's too much to it to try and fit it in to a short session at the end of this week. So we're going to kick off next week with decimal place value, which may take up to 2 days to really look at how decimal numbers can be mastered as well. From there, we're just going to be taking a couple of examples of mastery of multiplication and division. We've done a lot of work on addition so far. We've not really covered anything so far in any of the training sessions on multiplication and division. So I'm going to take a couple of key elements of each of those and show you how they can be taught within the mastery approach. So thank you so much for bearing with me this week. I hope you've had a really enjoyable week and see lots and lots of examples of good practice that you'll be able to build in to your lessons on place value at the start of next year.
Thanks so much for joining me for this week's work on place value. I hope you've been a little bit inspired by the variety of approaches we've taken this week and that you have seen lots of different ideas and activities that you'll be able to use back in school, if not straight away, then hopefully by September when place value is being taught in quite a lot of depth at the start of the year. Thanks so much. We are going to start next week, as mentioned, with a session on decimal place value, and then we're going to move into some other areas of mathematical mastery. Again, thanks very much for watching, and I'll see you all next week.